Hello, my dear students. I hope you all are good and will be doing great at your home. My name is Atul Kumar Singh, and I'll be your tutor for today's session. And I have more than 9 years of teaching experience. And throughout all my 9 years of teaching experience, I have taught the students in such a way that they have fun while learning the maths because they feel that it's really boring subject, right? Isn't it? Yeah, yeah, obviously. But if you're following right approach, if your basics are clear, so obviously you will be loving maths, right? So that is why I'm here just to let you know few really important thing, and that is going to be really important for you, right? Because this thing that I'm going to tell you here in this session is going to be really important. It is going to help you just to improve your calculation, right? Okay, but I have a surprise for you all. Now, what it is, I'm not going to tell you the topic name that we are going to learn here. You have to guess it, and obviously, I'm gonna help you just by giving you some clues, right? So you have to just guess it, okay? But for that, I'll be asking few questions to you all, right? And honestly, you need to answer, right? Okay. And you have to promise me whenever you are not getting anything, you will stop me and you will ask the question. Yeah? Promise? Okay, perfect. And one more promise, it doesn't matter how many times you wanna ask. If it is not clear, you can ask the question, right? Just stop me and ask the question because you are here just to learn the thing, right? Okay, let's get started. Okay, are you ready? How many of you are ready? Everyone. Wow, very good. Okay, so suppose I have 30 chocolates and I just wanted to divide among 9 students. How do I get to know whether I can divide 30 chocolates among 9 students equally? Right? Look, I just want to divide 30 chocolates among 9 students. Yeah? You wanna divide, but among all of you? You wanna divide among all of you? Okay, you can divide, but first of all, answer this question. My question is, I want to divide 30 chocolates among 9 students equally. So can I divide? Obviously, it's a smaller number. I mean, 30 and 9, they are the smaller numbers, so you can just find it out here just by using long division method. You can say, sir, I can just divide 30 by 9. 9 3 times 27, right? And then we are left with 3. It means we cannot divide 30 by 9 completely, right? So how do I get to know without just dividing the number? How do I get to know that I can divide 30 by 9 or any other number by any other number, right? How do I get to know? Suppose I have a number, suppose I have 3,472 chocolates, and now I just wanted to know, can I divide these chocolates equally among 9 students? How is it possible? So basically now here we have a really big number, right? And if we are going to use, long division method, so it will take a lot of time. And if it is taking a lot of time, so it is not going to work. So I have something for you all, right? Without using long division method, without dividing, you can just answer whether this number is completely divisible by 9 or not. Even I can let lot of concepts. I can just let you know few rules that you can apply, and without dividing any number you can just find it out whether that number is completely divisible by any other number or not, right? Are you surprised? Yes, you should. Okay, yeah. So basically here, any guess what is the topic name that we are going to learn here? I'm talking about the divisibility, right? And I'm talking about the rule. So the topic is divisibility rule. That's it. Yeah. Okay. So here we are going to learn about the divisibility rule. Okay. So I'll be starting with the first of all divisibility rule of 2, 4, and 8. Okay. And then after I'll be letting divisibility rule of 3 and 9. Yeah. So first of all, I just let you know here divisibility rule of 2. If you wanna check whether any number is completely divisible by 2 or not. So without dividing that number, without you know completely dividing that number, how do we get to know that this number is completely divisible by 2 or not? Look, so you need to just check the last digit of the number, right? Suppose I have a number 748 and I just wanted to know whether this number is completely divisible by 2 or not. So what I'll do, I'll just check the last digit here, 8, right? If 8 is completely divisible by 2, it means the number is also completely divisible by 2. Suppose I'm talking about here 1272. So if I need to know whether this number is completely divisible by 2, whether without dividing the whole number, so what I'll do, I'll just take 2, which is unit digit, right? And I'll just divide 2 by 2. If this unit digit is completely divisible by 2, so the number is also divisible by 2. That's it. This is the only one rule that you need to remember, right? Okay, now you must be thinking, why only the last digit, right? Why cannot we take the first digit or the middle digit, right? That's really good question. Look, so basically what happens here, I mean, you can just, if I'm talking about 10, so you can divide 10 by 2, right? Completely, right? So 10 is completely divisible by 2. So that is why suppose anyhow, if we are getting any number, right? For an example, what I'm saying here, it's 748. Now you have to just write the number. You need to just take out 8 from here. I mean, just you need to take out unit digit. So can I say here I can split 748 as 740 plus 8. The way I'm speaking, I'm just splitting it. 740, 748, 748, right? Now I can see here 740 can be written as 774 times 10. And I know 10 is completely divisible by 2, which means 740 is also completely divisible by 2. Now we are left with 8. And what it is basically? A number? A digit? Yes, it is, but what it is actually what it is. So basically you can see here 8 is the unit digit, or you can say the last digit of the number, right? Okay, let me take one more example. Suppose I just wanted to check 1296. 1296. So I'm going to write here 1290 and plus 6, right? I know here we have 1290, so I can just write it as 129 times 10, right? And if we have 10, it means it is completely divisible by 2. So if 10 is completely divisible by 2, which means that number 1290 is also completely divisible by 2. Now what we are left with? Only 6. So we need to just check whether 6 is completely divisible by 2 or not. And what is 6? Again, 6 is the last digit of the number, right? So that is why here, this is the basically concept. That's why we are checking here whether any number is completely divisible by 2 or not. So that is why we are just checking only the last digit, right? I hope you got it. Okay. Now, the way 10 is completely divisible by 2. So can I say here, if I'm writing here 10 over 2, I mean, we are just multiplying 10 over 2 times 10 over 2. So this is going to be here 100 over 4. So which means, can I say one thing? That if 10 is completely divisible by 2 and this 10 is also completely divisible by 2, so can I say that 100 is completely divisible by 2? So the way here we were just dividing number in such a way, we were just splitting the number in such a way so that we can get 10. Now here we'll be splitting the number in such a way that anyhow we can get 100. I mean, two zeros at the end, right? So for an example, I have 432. This is the number. I just wanted to check whether this number is completely divisible by 4 or not. So what I'll do, just you need to check the last two digit, right? What says the divisibility rule of 2? Just check the last digit of the number. If the last digit of the number is divisible by 2, so the number is also divisible by 2. But what about 4? So here it says if the last two digits of the numbers are divisible by 4, the number is also divisible by 4. So I need to just check 32. If the last two digit is completely divisible by 4, which is actually divisible. So it means I can say 432 is also divisible by 4. Now basically what is the logic? So I can say I can just write it as 432 can be written as 400 plus 32, right? And now I know here it is 4 times 100 and 100 is completely divisible by 4, which means 400 itself completely divisible by 4. Yeah. Now what we are left with? We are left with 32. And what it is basically? This is basically, I mean here 3 and 2, they are the last two digit of the number, right? So this is basically the concept here, right? So that is why here we are just checking last two digit of the number, whether it is completely divisible by 4 or not. If any number, suppose I have 1768, if I just wanted to check whether this number is completely divisible by 4 or not, so what I'll do, without dividing, I can just check the last two digit. So last two digits we have 6 and 8, which is 68, and it is completely divisible by 4, which means the number also completely divisible by 4. That's it. Yeah. Okay. So if we have 10 over 2, right? And one more time 10 over 2 and one more time 10 over 2. Since everywhere 10 is divisible by 2, 10 is divisible by 2, 10 is divisible by 2. So can I, if I'm multiplying all these numerators and denominators, so I'm gonna get here 1000 over 8. So individually, if 10 over 2 is completely divisible, it means here also if I'm dividing, so I'm gonna get here 125, right? So basically what is happening? 1000 is completely divisible by 8. So the way we were splitting the number when we were checking divisibility rule of 2 and 4, in 2 we were just splitting the number in such a way that we should get 10, right? I mean we should get 1 0. In 4 we were taking two zeros. Now in divisibility rule of 8 we need to take three zeros. And how do we get 30? What I'm talking about actually, suppose if you have 1672 and I just wanted to check whether this number is completely divisible by 8 or not. So divisibility rule says just check the last three digit of the number, that's it. If the last three digit is completely divisible, so 672, let us divide it. So 8 one times, 8 8 times 64. Now 3, we are left with 32 and 8 4 times 32, which is completely divisible, right? It means this number is also completely divisible by 8. But what is basically the concept here? Right? What is the pattern that is going on? So I can write here 1000, right? I can write 1000 plus 672, right? I know 1000 is completely divisible by 8, so now we are left with here 672. I need to just check whether the 672, which are basically the last three digit of the number, whether they are completely divisible by 8 or not, right? So if they are, it means the number is also divisible by 8. If they are not, it means the number is not divisible by 8, right? Okay, so let us just have a quick recap what we learned. We learned about the divisibility rule of 2, 4, and 8. So whenever you want to check any number is completely divisible by 2 or not, so what do you check? Yeah, tell me, what do you check? The last digit. And in 4, last two digit. And in 8, last three digit. Yeah, very good. Okay, now the next thing that we are going to learn here, how do we check any number is completely divisible by 3 or 9 or not, right? Suppose you have a number 742 and you want to check here that this number is completely divisible by 3 or 9 or not, right? So what you have to do here, just you need to add the digits here, right? So 7 plus 4, 11, 11 plus 2, 13. So 13 is not divisible by 3, right? What you have to do, you need to just add the digits. Whatever sum that you are getting, just divide that sum by 3. And if the sum is completely divisible by 3, it means the number is divisible by 3. If the sum is not divisible by 3, it means the number is not divisible by 3, right? So here basically what we are getting, 7 plus 4, 11 plus 2, 13, and 13 is not divisible by 3, it means the number is not divisible by 3. And if you want to cross check, so you can just use long division method, 742, 3, uh, uh, 3 two times, right? 6, 1 is the remainder. Now I'll take 4 down here. And 3 4 times 12, I'm left with 2 and 2 more. So 3 7 times 21, and now I'm left with 1 here, right? So this is my remainder. It means it is not completely divisible by 3, right? Okay, now let us check here 7641. I need to check whether this number is completely divisible by 3 or not. So what I'll do here, 7 plus 3, 13, 13 plus 4, 17, 17 plus 1, 18, right? So 18, I need to check whether 18 is completely divisible by 3 or not. Yes, it is. It means the number is also divisible by 3, right? If I need to check whether this number is completely divisible by 9 or not, so again I'll do the same thing, right? I mean, I need to add all the digits, and if the sum of all the digits is completely divisible by 9, it means the number is also divisible by 9, right? Basically, why we are following this pattern? I mean, why we are adding the numbers here? Look, what happens actually when you are dividing 10 by 3 or 9, so always you will be getting 1 as a remainder, right? And again, if you're dividing 100 also by 3 or 9, so you will again be getting 1 as a remainder. In the same way, if you are dividing 1000 by 3 or 9, so again you will be getting 1 as a remainder, which means basically what I can say overall, whenever you are going to divide 10 or 10 to the power any number by 3 or 9, so always you will be getting 1 as a remainder, right? So suppose I just wanted to check here whether 432 is completely divisible by 3 or not. So can I write here 432? 400 can be written as 4 times 100. 30 can be written as 3 times 10 and plus 2, right? Now I know if I'll divide 300 by 3, so I'm going to get 1 as my remainder. So 4 times 1, which is 4. If I'll divide 10 by 3, I'm going to get remainder as 1. So 3 times 1, which is 3, and then plus 2, right? Now what we are left with? 432. And my dear students, basically what 432 are? They are the digits of the number, right? So that is why I'm saying here, this is the pattern that is going on basically here, right? So that is why here, whenever we want to check whether any number is completely divisible by 3 or 9 or not. So what we used to do here, that is why here we are adding the digits, right? And then we are getting to know whether the number is completely divisible by 3 or 9 or not, right? Okay, suppose I have a number here, this number, and I just wanted to know whether it is completely divisible by 9 or not. So what I'll do, I'll add all the digits, right? And whatever sum that I'm getting here, I need to just check it whether it is completely divisible by 9 or not. If it is divisible, it means the number is also divisible. But what about those students who are struggling to add a lot of digits, right? If they are going to add, smaller digits, I mean, only few digits, 1 or 2 digits, so they are okay. But whenever they do have a lot of digits, I mean, 4 to 5 digits, 5 to 6 digits, so they are, getting irritated, right? So they used to get irritated. So that is for those students, I can tell you one more really easy and interesting thing here, right? What you can do, instead of adding all the digits, now what you can do here, you can individually divide all the digits here, right? What does it mean? What I'm saying here. Okay, first of all, let us talk about 3, divisibility rule of 3 here, right? If I just wanted to check here whether this number is completely divisible by 3 or not. So what I'll do here, instead of adding all the numbers, what I'll do, now I'll divide each and every digit by 3. So I know 6 is divisible by 3, I'll cancel it out. And then we don't have any digit which is completely divisible by 3. But what about if I don't have single digit, but 7 plus 2, 9 is divisible, so I'll cancel it out. 5 plus 4, 9, divisible by 3, and 7 plus 5, 12 is divisible by 3. So now we are left with no number here, right? It means this number is completely divisible by 3. In the same way, I have this number 7, 6, 5, 5, 4, 7, 2. And I just wanted to check whether this number is completely divisible by 9 or not. What I'll do? I do have here basically 9, right? Suppose I have 9, 9. Now I want to check whether this number is completely divisible by 9 or not. Now I'm not going to add all the digits at all, right? Because it's really complicated for me. So that is why what I'll do, I'll just cancel out 9 and 9. Why? Because 9 is divisible by 9, that's why. Okay. Now 7 is not divisible by 9, but yeah, I know that 7 and 2, 9 is divisible by 9. 5 and 4, they are not divisible by 9, but 5 plus 4, 9 is divisible by 9, right? Then 7 plus 5, 12 is not divisible by 9, plus 6, 18 is divisible by 9, right? So that is why together we can add them and we can get it. Because I told you, look, you can, I mean, every student can add 2 to 3 digits, but they have problem when they have to add a lot of digits. I mean, 8 to 9 digits together. Then they have problem, right? So that is why instead of adding all the digits, what you can do, you can just individually divide each and every digit, right? And if you are not left with any number there, right? So it means the number is completely divisible. And if you are left with any digit or any remainder, obviously the number is not divisible by 3. For an example, or 9, right? For an example, here I have 7, 4, 6, 9, 4, 3, 2, 1, 0, 9, 8. I mean 6. I just wanted to check here whether it is divisible by 3 or not. So 6, I can cancel it out. 9, 3, 2 plus 1, 3, 9, and 6, right? And then after 7 plus 4, 11. 11 plus 4, 15. So it is completely divisible. Okay. So let me take 2 here, right? So 7 plus 2, 9. 9 is completely divisible. So 4 and 4, now we are left with 4 and 4, 8, right? So 8 is not divisible by 3, which means the number is not divisible by 3. That's it. This is the only thing that you have to do, right? Okay. Now, since we are running out of time here, so we are not going to learn furthermore divisibility rule here. But I hope you enjoyed this one, right? And basically, instead of enjoy this one, this is basically, why we are learning here, because this is going to help you to improve your calculation, right? This is not just a magic that I'm showing you over here, because this thing can help you just to get to know whether any number is completely divisible by any other number or not in just few seconds, right? If your calculation is good, you are pretty good with the smaller number, so you can quickly, if you are good in addition, right? So obviously you can just get to know whether any number is completely divisible by any other number or not, just in few seconds, right? Basically it will help you to improve your calculation, as well as it will help you to grow your just improve your mental calculation as well, right? Okay, so let's quickly recap all the thing whatever we have learned so far. So we learned the divisibility rule of 2 and what it is. Just we need to check the last digit, right? If the last digit is divisible by 2, it means the number is divisible by 2. For 4, we need to check the last two digits, right? If the last two digits are divisible by 4, it means the number is divisible by 4. For 8, we learned that if the last three digits are divisible by 8, it means the number is also divisible by 8. And then we learn for 9 and 3, if the sum of all the digits, right? If the sum of all the digits is completely divisible by 3 and 9, so the number are completely divisible by 3 and 9, right? And also I told you for those students who are used to struggle while adding a lot of digits, so I told them that you can just what you can do individually, you can just divide them, right? And if you are not getting any number which is individually you can divide, so you can just add 2 to 3 digits, right? That is one thing that you can do here. Okay, I hope all the things are pretty clear. But yeah, if they are not clear, you can just let me know. So basically, why we learned this thing? Because I want you to improve your calculation. Because mathematics is nothing but just you can say here the calculation, right? If your calculation is not good, obviously you will not feel confident, right? And if you are not confident, you cannot solve the question. That's why maths feel scary, right? That's why you student used to say it's boring, because they don't have the right part to do, right? If you have the right concept to do, if you are following the right parts, obviously you can perform really better, right? So in the next session, obviously I'm gonna take few more things just to let you know here, right? And they are going to be really interesting again, right? I hope all the things are pretty clear. Now can we end the session here? Yeah, what's it? Can we? Okay, so now I'm gonna end the session here. Bye bye, take care, be happy and be healthy, and please do revise all the things once again, right? And if you're struggling, just drop a message over here. I'll be here to help you each and every point, right? Bye bye, take care, be happy and be healthy, and see you soon again.